Grades 10 and 11 students are participating in a cross-graded project focused on developing their inquiry skills and their knowledge of energy. They're doing this by building model rockets in class. The teachers focused on particular shifts towards student-centered learning.
In my Physics 20 class and my Science 10 class, we built model rockets. The main purpose of doing it was to show the different energy conversions, so the kinetic, the potential energies, the stored energies. With the Physics 20s a bit, we touched on Newton's laws. Kids made posters and how it related to the first, second, and third law. We just wanted to make sure with this that the Physics 20s and the Science 10s, because of the different curricular expectations, that their assignments reflected that accordingly.
So my Science 10 students were originally working on a pendulum lab to measure both kinetic and potential energy in the form of mechanical energy, and then the conversion between the two. From that lab, we decided that we were going to try to do something that was a little bit more cross-curricular and competency-based, as opposed to teachers standing at the front saying, here's a pendulum, this is what it looks like, here's the lab, go complete the lab.
Okay, now the rocket won't fire perfectly straight. It may go in an angle, that's fine. It may get carried by the wind. But what you're looking for is you're looking for the maximum height.
8, 7, 6, 5, 4, 3, 2, 1. Where'd it go?
So we had students divided into 3 groups. One was our launch pad crew, so they would go to the launch pad and they would help set that up, and obviously that was one of the more popular jobs. We had a clinometer group, so those are the people who were with me, and they were using this to measure the angle of inclination for the rocket. We had at least 5 up at a time, of course, so that we can measure record different data, take an average, take an educated guess. We also had our field crew, so they were the ones who were out in the field, and their task was to recover the rocket after it had been fallen, and that was a lesson in itself. People didn't realize how hard it was to find a falling object, especially with snow on the ground. White rockets, once they're in the ground, they're lost.
Students analyzed, interpreted, and applied the concepts they were learning to both formative and summative assessments.
Their physics test right now. So it's tying into, you have the transform initiatives with more, the kids taking ownership, doing more of the project inquiry base, but we're still bringing them back to traditional assessments as well.
Students developed many competencies throughout this project.
It helps us remember, especially during finals.
Yeah.
When we actually experience it, I'm like, oh yeah, I remember the rocket too, so we have force of gravity and stuff.
Fantastic.
Yeah, it helps us for our exams. That's the thing. It helps us in the future too.
We also got to work with other classes and other teachers to help us build the rocket and launch it and solve for force of gravity and how high it went. So we got to work with more than just ourselves and so we got to work with other people.
I remember some of the grade 10s were like so amazed. I was like shouting when the rocket flew. They were like, oh my god.
They were excited.
It's so high.
Yeah.
I didn't know it's going to be that high.
Yeah.
Really?
Yeah,
Yes.
it's really high. It's just a small rocket like that, but it went up. How many meters?
48 meters.
So Teresa was really great. She actually met with me first when we met with Brian Fowler, the department head. She kind of had an idea of exactly what she wanted to do with what unit. Then we looked at how could we expand that unit and how could we really get the students out of the classroom, out of a lab type setting, even outside of those 2 elements that they're used to.
Well, one of the strengths that we saw that happened, and the teachers shared this, was that we had students in Physics 20 working with students in Science 10. The fact that those 2 different classes were able to work together, the learning that occurred, the teaching that occurred within those 2 classes, students shared that learning. If there's an opportunity for us to use cross-curricular classes again in any kind of project, I think it's something that we're seriously going to approach. We have always looked at things from the humanities perspective and the science-math perspective, but when the students were engaged in this activity and they could actually explain, the physics students could explain to the Science 10 students what this meant, and the math that was included into that, when those students returned back to the classes, we think that there was a stronger understanding of what they were doing within that class. Those connections were so important. So if we can allow that to happen in any kind of way for next semester or through the year, we'll certainly look at doing that again.